All right, so 4, 5 is just going to be the graph of the other 4 trig functions. Okay, so the technique that we've been using to graph the sine and the cosine are going to be the exact same steps that you're going to take for drawing cosecant, secant, cotangent, and tangent. Okay, the only difference is they just look different. Okay, so instead of the nice little pretty wave, they have a different look to them. Okay, and the nice thing is that tangent and cotangent look the same, and secant and cosecant look the same. Okay, so let's start with tangent. So we'll do the tangent of x. We'll just say is equal to y. Okay, so this is your basic parent function. Okay, so you can think that, first of all, what's the amplitude on this? 1. Okay, so maybe you want to write that, because that always helps. The period in this is 2 pi over the b. What's the b value? 1, so 2 pi. Is there a phase shift? Vertical shift? No. Okay, so same exact thing I'm going to do as I did for the sine and the cosine. So I draw my little axes, I draw 4 increments. 1, 2, 3, 4. Okay, then I'm going to label the 4th one what? 2 pi, so whatever the period is. Okay, and then I'm going to label all the way back to the first one. So half of 2 pi is pi, so my first increment is pi over 2. Because I really don't care. All I really need is how much each increment is worth. So if there was a phase shift, I would know what each increment means. Third increment would be 3 pi over 2, if you felt like labeling it. Okay, so for my amplitude, how high and how low do I need to go? 1. Okay, so now the difference on a tangent is it just looks different. Okay, so I'm going to draw this and see if you start to know it. I'm going to do 1 increment in the negative direction because for tangent, it actually, you're going to draw your period left of it. So this is what it looks like. It's not just a John Travolta. It's like a dance party. It's a whole bunch of John Travoltas forever in both directions. Okay? The coolest, yeah. Okay, so what is really important of a tangent function is that there happens to be vertical asymptotes. Okay? The vertical asymptotes are essentially splitting each of these John Travoltas apart. Okay, so I'm going to kind of describe that there's a vertical asymptote. Okay, and it will always be on the first increment of a John Travolta of your x-axis. So my first increment is what? Pi over 2. And then it will always occur every pi units. So the way I'm going to say that is n pi. So every 2 increments. Okay? So the reason I'm saying plus or minus is because you have to realize that this does go in both directions, right? To negative infinity and positive infinity. So that's counting all of the vertical asymptotes in this entire function. Okay? So if there's these vertical asymptotes, what happens to be restricted for a tangent function? The domain. Very good. Okay, so this is another thing that they're going to ask you about. What is the domain and the range of these functions? Okay, so for domain, it's going to be all of the reals except where those vertical asymptotes are. Okay, so you can say all reals except what I just said for those vertical asymptotes. Pi over 2, that was the first one. and every 2 increments. So 2 increments is a distance of pi. And that will always hold true. No matter what your period is, it will always be every 2 increments. So if you want to give yourself a note right here, that value comes from the first increment. How do you spell increment? Increment. Yes?
So would the vertical asymptote change?
Yep. All of it gets moved. Yep. Is it increments? That looks wrong to me. I'll just draw really sloppily. Perfect. And then this distance, the pi, will always come from the second increment. I'm going to say inc. There we go. Perfect. Okay. By the way, what's the range of this? Right. All reals, right. Perfect. Okay. It goes down from negative infinity to positive infinity. Okay. So there is a tangent. So I'm going to immediately go to cotangent because cotangent looks very similar to the tangent function. So cotangent of x. I'm going to use a different color. Blue. Cotangent. We'll do cotangent in blue. Okay, so what's the amplitude of this? 1 again, period. 2 pi. Nothing's changed yet. Okay, so I draw my 4th increment, and my 4th increment is going to be 2 pi. So half of that is pi, and half of that is pi over 2. And again, I'm going to go 1 in the negative direction. Okay. How high and how low is my y going to go? 1 to 1, right? 1, negative 1. Okay. So on a cotangent, we also have a dance party. But it looks like this. So I could even go right here. Okay, so tell me what you immediately notice about these John Travoltas. What's that? It's moved over, okay, pi over 2 units, and what else? And flipped. Okay, so on a cotangent, the left arm is up. On a tangent, the right arm is up. So if you were just looking at a random function and you saw a bunch of right-armed John Travoltas, you'd immediately know that it was a tangent function. Unless, of course, it was flipped upside down. Uh-oh. Right, so those are really easy to duplicate, just like sine and cosine. Okay, so let's talk about this one. Again, we have vertical asymptotes. Where are the vertical asymptotes? Where's the first one? Okay, so now that's kind of a hairy line right there. Where's the first one, right? So Skylar immediately said 0. My instinct is pi. Can't really say there's a first one because it goes in infinite direction. So if you want to say 0, that's fine with me. You can say 0 plus or minus, okay, how far is 2 increments? Pi again, so n pi. So it's again, it'll always be 2 increments for tangent and cotangent. No matter what. Period. Bottom line, always. Okay, so if we were going to quickly list the domain, what's the domain on cotangent? Or excuse, yeah, domain on cotangent. All reals except, I'm just going to say plus or minus n pi. What's my range? All reals. Awesome? Hanging in there? Okay, so let's go to secant next. So we're at 3. Or let's do, yeah, cosecant first. Let's do cosecant. Cosecant. Okay, so remember that cosecant is the reciprocal of sine. Okay, so that is used actually in figuring out what the cosecant function looks like. So this is kind of an interesting one. So again, we have an amplitude of 1 and a period of 2 pi. So that all stays the same with that. Okay, when I go to draw my function, I'm going to start exactly the same way. I'm going to do 4 increments. Fourth one is 2 pi. Half of that is pi. And half of that is pi over 2. And again, I'm going to go in the negative direction because it does exist over there. Okay, for my amplitude, how high and how low? 1. So leave yourself a little bit of room here above 1 because the function actually exists above 1. Okay, so what I'm going to do, I'm going to draw this in gray. Okay, so you don't draw this on your paper. I'm just going to draw this so you can see what happens. So remember how I said cosecant is reciprocal of sine, right? Okay, so I'm just going to quickly draw the sine function on here. So sine starts at the origin, goes up, comes back down, like that, right? So just kind of keep going. Okay, so here is what cosecant looks like. Okay, so kind of the best way to describe this one, I drew that last one really low. I don't like that on your draw. It looks like a bunch of parabolas, right? And what do you notice about the parabolas? Right. Okay, so I've heard the term kissing cousins. Do you see where that kind of comes from?
The South.
See how? Okay, maybe we shouldn't say. Let's call it kissing functions. How about? Okay, so these maxes and mins like touch each other, right? And it's kind of like somebody took scissors and like cut right along the midline and then reflected them. Okay, so that's kind of what happened. So for a cosecant function, again, we have vertical asymptotes. Let me erase all that sine stuff. Okay, so we have vertical asymptote. Oh, good lord, sorry. One too many undos. Here we go. So we have a vertical asymptote. Good lord, come on, here we go. At x equals, okay, so where's my first vertical asymptote on this one? Where? At pi. So you can say pi or 0. If you're Skylar, you say 0. If you're me, you say pi. I don't care. Either way. 0 plus or minus, and how far is 2 increments? In pi. Okay, so we can say my domain is going to be all reals except 0 plus or minus n pi. And the range is, ooh, what's the range? So how low?
From 1 to infinity.
Yeah, so this is kind of a split one. So it's like from, yeah, you said it backwards, but that's okay, I understood. So it goes from negative infinity to -1, and I should technically include -1 because it does actually hit it, max out, and then from 1 to infinity. So it's like the exact opposite range of a parabola, or of the sine function, excuse me. Okay, if you remember, let me know. So we good there? Why did I skip pi? How do you figure that I skipped pi? What do you mean by that? Yep, it's a vertical asymptote. So those max and mins hit right at every 2 increments, right?
So neither put 0 for
Yep. Okay, last one. So cosecant looks just like the secant one. So secant is our last one. So again, we have an amplitude of 1, a period of 2 pi. So again, we go 4 increments, 1, 2, 3, 4. Fourth increment is 2 pi, half of that is pi, half of that is pi over 2, and I always do 1 in the negative direction. For my amplitude, I need up 1, down 1, but I need it kind of like in the middle, because the function exists above 1 and below negative 1. Okay, so if I was going to draw this one, I'm going to do the same thing, and remember that secant is the reciprocal of cosine, right? So cosine starts at 1, right? So it goes like this. Cosine looks like this. So that helps me draw my cosecant. So this max is going to be the bottom of a parabola right here. And this min will be the top of a parabola. Okay, so again, these parabolas keep alternating up and down from negative infinity to positive. So just like a whole bunch of parabolas. Okay, so vertical asymptote for this one, where's my first one? Pi over 2. So pi over 2 plus or minus n in 2 increments is a distance of pi. Okay, so if we list the domain is going to be all reals except pi over 2 plus or minus n pi. And my range is going to be the same as my cosecant. So from negative infinity to negative 1, and from 1 to infinity. Okay, so before I go and do an example with some kind of shifts happening, I want to quickly just go back and start to see maybe helpful hints. So for me, one of the things that are really valuable is where do all of these vertical asymptotes start? Okay, so if you look at the domain of all 4 of the functions that I just drew, which 2 have the same domains? Which function has the same domain as the tangent function? The cotangent. Okay, no, the secant one, not cotangent. Okay, so secant and tangent have the same domain. So they both have a vertical asymptote that starts on the first increment. Okay, and then the cotangent and the cosecant both start at 0. So the way I remember this, just as a hint for you, what do you notice about cotangent and cosecant? Like, very simply, they both start with the letter C. So that's how I remember, is I remember that the 2 functions that start with C have a vertical asymptote that start at 0. And the other ones start at 1 increment to the right. Okay, so that's just how I remember. Okay, are you ready for this? Let's do a shift. Let's see, we'll do a blue example. So let's do a tangent first. Let's do 2 tangents of 2x. So not incredibly complicated. Oh, let's do a plus. Let's add it. Let's make it a little bit more fun. Plus 3, because that's not too hard.
The range of the secant function was it? What was the range?
Secant and cosecant are the same, so from negative infinity to negative 1. and from 1 to infinity. Okay, here we go. So first thing I want to list is my amplitude. What is my amplitude? 2. Then I go to my period. So 2 pi divided by b. What's my b value in this case? 2. So what is my period? Pi. Do I have a phase shift? No. Good. So I'm going to say none. Do I have a vertical shift? Yes. What direction and how far? Up 3. Perfect. Everybody good there? Step 1. Okay, now step 2 is going to be to label our axes and to label them correctly. Okay, so if you are not labeling your axes, you're going to lose a lot of points on your quiz or test, whatever I give to you. Okay, that is going to be part of the points that I will be looking for. Okay, so 4th increment is what? Pi. So what's half of pi? Pi over 2. What's half of pi over 2? Pi over 4. Okay, and I'm going to do 1 in my negative direction. Okay, so for a tangent, is the amplitude vital? Okay, so if you think about the amplitude, it's not really telling me how high and how low it goes, right? Because it's a John Travolta, it goes to infinity and to negative infinity. So it doesn't really matter. If I have a 2 or a 20 right there, it's still really going to look very similar. The only thing it will affect is how steep it is. Okay, which when you're drawing that, I will have no idea what amplitude you technically are drawing. Okay, so on a drawing, amplitude doesn't matter. Okay, but what does matter is a vertical shift. Okay, so what is my vertical shift for this? Up 3. Okay, so that's going to take my midline up 3. Okay, and I'm just going to get in a habit of always drawing a midline because that is just helpful all the time. Okay, so I know I'm drawing a bunch of John Travoltas that have been moved up 3 units. The first thing I'm going to draw is my first vertical asymptote. Where is my first vertical asymptote going to lie here? At pi over 4, the first increment. Tangent will always have a vertical asymptote at the first increment. Unless, of course, it's moved to the left or the right, which then you just take it from there and move it. Okay, so I'm going to literally draw my vertical asymptotes. Okay, so I'm going to have them every 2 units. See how nice and easy this becomes? Okay, so now I'm going to go ahead and draw. I'm going to draw the John Travolta with which arm up? The right arm up. He's going to do his wiggle at the midline, so I should be able to see that you wiggle there. Okay, so I should draw in between those asymptotes. Okay, and all I need to see is 2 John Travoltas. If you'd like to keep going and draw 3 John Travoltas or 4, that's fine, because it does exist more. But I only need to see 1 full revolution, and 1 full revolution is 2 John Travoltas. Okay, so you need at least 2. Okay, let's do the domain and range of this just really quick because I bet they'll ask that. Okay, so domain. Okay, I have a restriction on my vertical asymptote. Where is my first vertical asymptote? Pi over 4. So I say all reals except pi over 4 plus or minus 2 increments. So how far is 2 increments? Pi over 2. See how 2, do you guys see what I mean by 2 increments? So I just use 2 increments from the origin. That's a distance. Okay, what's my range? Good, all reals. So how do we do on that one? Pretty easy? Incredibly complicated? Mediumly complicated? Okay. Okay, let's do an example with a. Let's do secant. So let's do y is equal to 2 secants. And I'm going to throw in, let's do a phase shift for sure. That's pi. Do I throw in a vertical shift too? Yeah, maybe not on this one. We'll just do just one shift. Okay. Let's start with that. Okay, so first of all, what is my amplitude? 2. My period? Pi, very good. So hopefully you said 2 pi divided by 2 in your head makes pi. Do I have a phase shift? Okay. What direction is my phase shift? To the right. Good. So I'm going to go pi over 2. Everybody good with pi over 2? C over B. So pi over 2 to the right. Good. And then do I have a vertical shift?
Is that so that x is by itself?
Yep. Yeah, you don't ever use the x because by definition, the standard form is bx plus c. So the b is just the number without the x. Just like when you're dealing with quadratics, when you're doing quadratic formula, you never use an x with it. So we said no vertical shift, right? So vertical shift, none. Okay, here we go. Pop that out. We got 4 increments. 1, 2, 3, 4. Fourth increment is pi. Okay, so I have half of pi is pi over 2. Half of pi over 2 is pi over 4. And of course I need the 1 in the negative direction. Whoops, I wrote 2. 4. Okay, so now for secant, I'm thinking about the amplitude. That's super important with secant. Okay, where are my little parabolas going to minimize and maximize that? 2 and negative 2. Okay, so I need to have up 2 and negative 2. And on secant and on secant and cosecant, I'm not going to draw the midline for those. I'm just going to draw the max and min, the amplitude pieces, because that's where my bottom of parabolas will be and tops. So I'm going to draw those out. They're kind of like asymptotes, but not really. But I'm going to draw them because they help me. Okay, so now the next thing I want to do is my vertical asymptotes. Okay, so if I go back to my original secant function, just the secant of x, where is the first vertical asymptote? At pi over 2, so the first increment, right? Okay, so let me kind of come up here and show you this. Okay, so normally a secant's first vertical asymptote would be at pi over 4, but we have a phase shift, right? I need to move this to the right pi over 2 units. First of all, how many increments is pi over 2? 2 units. So I need to take this and move it 2 units to the right. Boom, boom. So this is my first increment. Everybody see that? So right on my third one. Okay, now what I'm going to do at this point is I'm going to like star this vertical asymptote to help me kind of understand what that's my first one, because that helps you with drawing parabolas, because your first vertical asymptote has a positive parabola to the right of it, as opposed to an upside down parabola. Okay. So I'm going to draw this every 2 increments. Which some of you might notice would still be the same as if I had no translation at all, right? Interesting. All right, so now I draw this. I draw my parabolas. I start with my first one and I draw a happy face right to the right of it, and then I alternate. Okay, so I should at least see 2 parabolas, by the way. 2 parabolas. Usually on secant and cosecant, I keep saying that word. You should be able to draw 3 pretty easily, but you need at least 2, because 2 would be 1 full revolution. Okay, so quickly my domain is all reals except, where's my first vertical asymptote? Okay, pi over 4. Did anybody say the third increment, like 3 pi over 4? Because you could say that was the first one because I kind of used that one. But it doesn't matter if you use pi over 4 or 3 pi over 4. Either way works because it's going to be every 2 increments. So I'm going to go with the easy one and go pi over 4. And then plus or minus. And how far is 2 increments? Pi over 2, good. Okay, for my range, what's my lower range? Negative infinity to what? From negative 2, good. And my upper range, 2 to infinity, nice. Okay, so should we do one more? Should I pull one off the assignment and do that one together maybe? Like a tough one? Or you guys got it?
Yeah.
You're good?
The first choice you said.
First choice. Okay, let's do that. So let's say assignment's going to be on page 277. Whoops. And let me take a look at it. All right, all I'm going to do is 2 through 16 evens for this. You guys ready? 10?
Yeah.
10. So 10, ooh, let's use a different color. 10. 10 is y equals the cosecant 4x plus 7 pi over 6. Did I write that right? Is that what you guys have? Okay, so amplitude. So you guys should be writing this every time. Like there's no reason that you shouldn't be writing this. The amplitude, the period, the phase shifts. Okay? That will be information I'll ask you on the quiz/tests. Okay, so what's my amplitude? 1. Curtis, you gonna write this down? It's part of the assignment. Period. 2 pi over what? Okay, so b is 4. So what's my period for this one? Pi over 2. Okay, phase shift. Do I have a phase shift? Sure do. And it's c over b, so I have 7 pi over 6 divided by 4. So since I'm dealing with fractions and I'm dividing by 4, what's that the same as multiplying by? 1/4. So I'm just going to multiply by 1/4 and then just multiply straight across. Okay, so this becomes 7 pi over 24. Yee. In which direction is that going to take us? To the left, good. Ooh, we're going to have to know a little bit about fractions for this one. All right, so we draw 4 increments. Fourth one is pi over 2. So what is half of pi over 2? Pi over 4. What's half of pi over 4? Pi over 8. And then I need at least one in the negative direction. Probably more. Okay, so my amplitude, how low and how high is this going to go? 1 to negative 1. Okay, and since I'm drawing a cosecant, what does this look like? from back far away. We're doing parabolas, right? Okay, so we're drawing the parabola, so I'm going to draw the max and min line for this. That'll help me. Okay, here comes the hard part. Ready? So we got to deal with this phase shift. So the first thing I have to think about is on the parent function of the cosecant, where is my first vertical asymptote? Zero. Vertical asymptote. Okay, so it starts at 0. So I need to take that vertical asymptote and shift it to the left 7 pi over 4. 24. 7 pi over 24, which is, okay. So what I'm going to do really quick is I'm going to actually use my calculator and just figure out, put it kind of into decimal forms to help me figure this out. Okay, I'm going to ignore the pi parts because everything has a pi in it. I'm just going to think about 1/8 and I'm going to think about 7/24 as decimals. Okay, so in my calculator, if I type 1 divided by 8, that's like 125.125. I just did it right here.
No. I was trying to figure out where you got 1/8.
Oh, did that make sense?
Yeah.
Okay, because that's one increment. So each of my increments is 0.125. Okay, and then 7/24 is 0.29-ish. Okay, so I have to move this to the right. So is one increment going to be enough? No. So let's figure out what 1/4 is. Oh, wait, I can do that in my head. What's 1/4 as a decimal? 0.25. Okay, that's pretty close. Okay, so I can say that 7/24 is going to be like a little bit further than the second increment. Does everybody follow that? Okay, so I'm going to say right about here, and I'm draw that vertical asymptote just a little bit to the right of that. And now I have to...
Left.
Oh, shucks. Left. You guys, I totally was going right. Okay, well then left. Back, back, back. Alright, then I need to go this way. Negative pi over 4. There we go. Everybody good with that side then? So I'm going to star this as my first one. Left, it did say left. So now I need to go every 2 increments. Okay, so it's like the next one over is like almost at the y-axis, but I need to go to the little to the left of it. So my second one would be roughly right here. And then 2 increments, the next one would be like right there, a little left of pi over 4, and then a little left of pi over 2. Okay, so once I get to this spot, it becomes pretty easy. Now I'm just drawing parabolas. Yes?
Instead of changing decimals, we would be easier to just do this back. Pi over 8, change that to something pi over 24, that's 3 pi over 24. Okay?
Right.
So then you know that each interval
It's
3
3/24. So 6/24. Yeah, that totally works. Absolutely. So if your brain works in fractions, do that. If your brain works in decimals, use decimals. Whatever works for you. Absolutely. Both ways will work. Okay, so since I'm drawing parabolas, I starred my first one. My first one is going to have a upward parabola right next to it. Okay, so I'm going to have one here, and then I alternate. So then I have one down here, then one up here. Okay. And luckily I don't have to list the domain because that would be a little bit more fraction work, but we can figure it out. How do we do on that one? Not too bad, right? Okay, do you want me to do number 14 with you? Okay, I'll do 14 and then I'll let you guys do the rest of them. So 14 is y is equal to secant times x over 5 plus pi over 5. Okay, so what's my amplitude for this? 1. At least they give us a nice amplitude. Period. 2 pi over, what's my b value? 1/5. So always get rid of the x. So 1/5. So if I'm dividing by 1/5, what's that the same as? Multiplying by 5. So what's 2 pi times 5? 10 pi, good. Okay, so I have a phase shift. What direction is my phase shift? Left. And I have to go pi over 5 divided by 1/5. Yes?
So pi.
Go ahead, Josiah.
Could you do?
Okay, so period is 2 pi over b, right? So if you're looking at the x, you see x over 5, which is the same, dividing by 5 is the same as multiplying by 1/5. Good? Okay. So everybody good with phase shift too? Is pi? Pi to the left? Good? Check? Okay. Here we go. Ooh, this is a big one. 10 pi. 1, 2, 3, 4. Fourth increment is 10 pi. So this one would be like if you were just graphing this on a normal 2 pi, like it would be totally pulled out really far. The xylophone. Xylophone? What is that thing? Is that a xylophone? No, it's not an accordion. Xylophone is the ding ding. You know what I was saying. 5 pi over 2. So each increment is 5 pi over 2. Everybody follow my math there? Okay, amplitude. How high and how low are we going? 1. So I need a 1 here. -1. Okay, so now since I'm drawing a secant, I'm going to go ahead and draw the max and min lines just like I did in the ones before. Because that's where my parabolas hit. Okay. So now I do my vertical asymptote. Okay, so secant. Where does the secant usually start? Which increment? If you go back to your original, it usually starts on the first increment. Okay, so if it normally starts on the first increment, we have to move it to the left pi. So where roughly am I going to hit? Yeah, I like that. It's a little bit to the left. Perfect, right? We could say 5 pi minus 2 minus pi and figure out exactly what it was. But when we're drawing it, we're going to say it's a little bit to the left of this.
How did you figure that out?
So if you would figure it out, you would do, if you wanted to figure out exactly, you would just do 5 pi over 2 minus pi. Which, by the way, pi is the same as 2 over 2, 3 pi over 2. That's where it would be, in case you wanted to know. Okay, so now we need to go every 2 increments. So the next one will be right about here-ish, a little to the left of that one. So now you can kind of make a judgment call, and you could go this way for your third vertical asymptote, or you could go this way. Doesn't matter. I'll just go both, just for fun. Two. So you got to at least show 2 parabolas. I always think it's best to show 3. So my first one, I forgot to start. It was right here. Okay, so here comes the easy part. So now I just draw a parabola to the right of it, and then alternate.
So the inverse of secant is cosecant.
The inverse of what? Secant?